To the first ever video of STEM Lab. I'm Brandon Diveston. Let's dive into kinetic theory. What is kinetic theory? Well, it has the word kinetic in it, which is attributed to motion. Overall, kinetic theory gives us clues to the motion of gas particles. For sake of ease, let me consider oxygen in its natural form O2. Well, kinetic theory hints that there exist regions between each molecule because the molecules do not have attractive repulsive forces. Combined with the fact that the motion of these molecules are random, the oxygen molecules can fill their containers regardless of the shape or size of said container. So, this leads to the logical conclusion that gases do not have definite volumes. Also, the path of an oxygen molecule is straight to begin with. Once this oxygen molecule comes into contact with another molecule, it will then change direction. Thanks to kinetic theory, we know that the oxygen collisions are actually perfectly elastic. This indicates that the kinetic energy of the particles combined remains constant. Did you know that collisions generate gas pressure? In reality, gas pressure is the result of the collisions of gas particles with an object. However, it takes numerous collisions simultaneously to generate large pressures. This pressure creation is also how air pressure occurs. Air particles collide, which allows for the effect. Also from this, and the fact that gases fill their containers, a vacuum or region with no particles has no pressure. With gas pressure, multiple units can be used, including the Pascal, atmosphere, and millimeters of mercury. This gas pressure is completely similar to vapor pressure. The only difference is that vapor pressure is generated by a container that includes both a gas and liquid. To understand how this works, I first need to tell what kinetic theory states about liquids. Unlike gases, liquids have attractive forces between particles, which gives a liquid substance a definite volume. Let me experiment with water. If I was to heat the water, the average kinetic energy of the molecules would increase. Now, it is important to note that not every molecule in the sample has the same amount of kinetic energy. The molecules with higher kinetic energies may be able to reach a kinetic energy limit where they can break free of the bonds holding them in liquid state. This is called evaporation. The vapor produced from the evaporation generates vapor pressure. When evaporation and condensation rates are equal, a state called dynamic equilibrium occurs. This means that no net change in the number of molecules of vapor or liquid occurs. There exists a positive correlation between temperature and Ke. If one increases, the other increases. So if I was to increase the temperature of the water, the average kinetic energy, or Ke, would increase, and more molecules could reach a minimum kinetic energy value. The boiling point of water occurs when the molecules throughout it have enough kinetic energy to break free of the bonds holding the molecules in liquid state. The boiling point can easily be calculated as it is the point where the vapor pressure equals the external pressure affecting the liquid. In most cases, air pressure is this external pressure, so it would seem as if there is one boiling point per liquid. However, air pressure changes with altitude. The higher you go, the less particles in the air are above you, so less pressure is experienced. Thus, the external pressure is lower on a mountain than at sea level. Overall, the normal boiling point is the boiling point most think about. At normal boiling point, the liquid's vapor pressure needs to equal the external pressure of 101.3 kilopascals. Be sure to hit the like button if you found this video enlightening, and subscribe if you would like to watch future videos. Thanks for watching, have a great rest of your day, and stay curious.